this Lagrangian is nothing but what? Half m r dot square and 1 plus b square r square plus 1 upon half m r square theta dot square minus mgb r square by 2. So we have to just go for equation of motion. So let's go for what is the equation of motion. So for obviously for r. So the equation of motion is d upon dt del L upon del R dot minus del L upon del R must be equal to 0. So this is our Lagrangian of a system. And first we have to calculate what is del L upon del R. So if this type of thing is there, you have to calculate each and everything separately. So what will happen? Del L upon del R is nothing but m r dot square b square r. I am just going to take the derivative of this one. So this all will there. So 2 and 2 will cancel out. And here you have m r theta dot square and minus mg br. So this is my del L upon del R. And when we are going for del L upon del R dot, then this value I have to only differentiate with respect to R dot, because this is just a partial derivative. So what we have, mr dot 1 plus b square r square. Now up to that, I think everybody is comfortable. But thing is that in a next level, what we are going to do, d upon dt, and when we have to go for del L upon del R dot, so then we have to differentiate this whole thing. So when we are going to differentiate this particular thing, mr dot 1 plus b square r square. So when we are going to take the differentiation, obviously we have to go for differentiation of r double dot. So this value is m r double dot 1 plus b square r square. And now you have to keep in mind that r is your dynamical variable. So if we are going for the total derivative with t, then this have to be also differentiable. You have to be also differentiate this term. So a lot of people will left this thing to differentiate this thing. So let's try to go for differentiating this particular thing. So what will be happen? So if you are going to differentiate it, then you have 2m, this r dot is here, and I am just keeping m r dot is there. We have to differentiate it 2b square r, and then you have to go for r dot. So this is total derivative. Now we have to go for minus del L upon del R. So this thing will be something like this. This will be minus m r dot square b square r minus mr theta dot square plus mg br. That must be equal to 0. And now these and these two will be compensate to each other. And finally, we can get the answer. So what will be my final answer? mr double dot 1 plus b square r square. And this value is plus m r dot square. Obviously, b square is also there. And now minus mr theta dot square plus mg br, that must be equal to 0. So deliberately I have given you this thing as your homework. This is very interesting, and you have to just practice it. Agar aapka galat ho gaya hai, to please try to practice this particular thing. Okay? Are you getting my point? Everyone is comfortable?
Yes, sir.
Okay, great. So let's go for our next problem. So next we are just going for what? Spring pendulum. So let's try to go for what? Spring pendulum. Yahan tak clear hai na? Everyone?
Yes, sir.
Good. So I hope कि आपने अगर गलती की होगी तो आपको अपनी गलती पता चल गया होगा, है ना?
Yes, sir.
Great. So next what we have, let's go for a spring pendulum. This is very interesting one. This is your mass m. There is a spring constant k. This is x. and this is in y direction. So there is also gravity in y direction. So spring pendulum constrained to move in xy vertical plane. So what we have to do, we have to first write Lagrangian of a system. We have to write Lagrangian of a system in Cartesian coordinate system, and then we have to write Lagrangian in polar coordinate system, and then we have to write equation of motion. We have to write equation of motion itself in polar coordinate system, but yes, we can write this Lagrangian into Cartesian coordinate also. So by the way, what is degree of freedom of a system? What is degree of freedom? There is one number of particle, so you have 3 into 1 minus, what will be equation of constraint? What is equation of constraint?
Motion in xy plane.
Very good. Equation of constraint is motion in xy plane. That means z is equal to 0. So that means there is only one constraint, and that is 1, and that is 1. So we have 2 DOF. Okay. So now if we want to write it in a Cartesian coordinate, then what will be my kinetic energy? My kinetic energy is half m x dot square plus y dot square. I can take this one as a 0, and this coordinate is x and y. So in this problem, writing the kinetic energy is not a big issue. The most important challenge is that how you are going to write potential energy of a system. So let's try to go for potential. हाँ बताइए.
Sir, due to this thing, there will be no restriction, na?
Due to there is a spring, there is not any restriction. A spring is not a restriction. A spring is just a manifestation of the some type of stored energy that will work parabolic. Okay.
Okay, thank you.
Okay, good, great. So let's go for our potential energy. So first we have to go for potential energy for the spring. So spring will store potential energy. What will be that potential energy? Suppose L is, or you can just assume L naught is natural length of a spring. Suppose it is also given N naught is natural length of a spring. So how you will write the potential energy of a system? What is potential energy? The potential energy is half K into change in length square, isn't it? K into change in length square, and minus, due to gravity, what we have? We have m, and this is plus आप यहाँ लिख लो, and that value is minus mgy. This is my y. Now the whole thing is that how you will write that delta L. What is delta L? Can anybody tell me what is delta L? Just try to write in form of x and y. बताओ किशोर क्या होगा delta L? बताइए. What is delta L? Sorry, क्या होगा? Delta L is present length minus original length. Okay, यही तो होगा ना? When a spring is not extended, what will be length? L naught. And when a spring is going to extend, what is that length? वो length क्या होगा? बता सकते हो? बताओ यहां से. Just tell me. What is present length? ये length क्या है? What is this length? बोलिए.
Square
X
root
square
of
plus
x
y
square
square.
plus
Very
y
good.
square.
X square plus y square. And what is original length? Minus L naught whole square. This is your stored energy in a spring. So what you have to write? You have to just go for mgy. This is my potential energy of a system. This is my potential energy of a system. Sorry. Okay. Now, what will be my Lagrangian? My Lagrangian is equal to half m x dot square plus y dot square minus half k root under x square plus y square minus L naught whole square, and this value is equal to what? The t minus v. So that value is minus. Sorry, this will be minus. Sorry, this will be minus. So this will be plus mgy. So this is my Lagrangian in a Cartesian coordinate system. Okay. So is that this Lagrangian is correct? How you will check whether this Lagrangian is correct or false?
Sir, GC must be equal to DF.
Very good. So how many DOF? 2 DOF, and your GC generalized coordinate is also 2. What are these generalized coordinate? X and Y. There is not any cyclic coordinate. Yes. Now we have to just go for a transforming the whole thing in a polar coordinate system. So if we are going for the polar coordinate system, then this is my spring. So what will be theta? If you are talking about polar coordinate system, you have to talk about r and theta, isn't it? What is theta here? Last class में बात किया था. What is theta? From the horizontal or vertical?
Vertical.
Sir, from the
Vertical.
Y.
For the vertical, always you will take this as your theta, and this is your r and theta. So what is your x? X is equal to r sine theta. What is your y? Y is equal to r cos theta. Now you can put it in this equation, and I hope you can do it easily. So that value is half m r dot square plus r square theta dot square minus k r minus L naught whole square plus mg r cos theta. So this is my Lagrangian of a system. So if this is my Lagrangian of a system, what are now generalized coordinate? What are not generalized coordinate? क्या generalized coordinate है?
Sir, R and theta.
R and theta. Is that any cyclic coordinate? Is that any cyclic coordinate?
Sir,
What is cyclic
no
coordinate?
cyclic coordinate.
No,
No
there is not any
cyclic
cyclic coordinate, isn't it? There is not any cyclic coordinate. So what do you have to do? You have to just write the equation of motion for r as well as equation of motion for theta. So let's try to go for first writing the equation of motion for r. So d upon dt del L upon del r dot minus del L upon del r must be equal to 0. Must be equal to 0. So I hope this will be m r double dot. So this m r dot is there due to del r upon del L upon del r dot. So this will be double dot. Minus r is here. So minus m r theta dot square. And this minus minus is plus k r minus L naught. And here we have minus mg cos theta. Just check it. सही कर रहा हो ना? You can also do along with me mg cos theta. Yes, and that must be equal to what? 0. Yes, correct है ये? चेक हो रहा है? कर पा रहे हो चेक?
Yes,
Yes,
sir.
just try to do with yourself also, please. आप कैलकुलेशन साथ साथ करते जाओगे, है ना? Is that it is correct? Yes.
Yes.
Okay. Just check it. Just check it. Now we will go for d upon dt del L upon del theta dot minus del L upon del theta is equal to 0. So you have to go for d upon dt del L upon del theta dot. Deliberately I have written here because when we are going for del L upon del theta dot, then R is also there. So it is very interesting. So we have m R square theta dot minus del L upon del theta. This is not a function of theta. This is function of theta. So mgr cos theta we will take the derivative, that will be minus sin theta. So here we have minus mgr sin theta must be equal to 0. Now we have to go for this thing, and here a lot of people are doing a wrong calculation. Why? First they will do it 100%. This is obvious, but R is also dynamical variable, so you have to differentiate it with this particular thing. So that will be 2m r dot theta dot plus mgr sin theta must be equal to 0. Just check it whether I am correct or false. सही है या गलत है, जरा चेक कीजिए. Just do it with yourself. साथ साथ करते जाओ. सही है ना? Okay.
Yes, sir.
Okay, great. So this is your equation of motion in R direction, and this is your equation of motion in theta direction. Okay. So this is
Sir.
one of the. हाँ बताइए.
Sir, cos theta will be minus sin theta. So
तो ठीक तो है. क्या दिक्कत है?
minus mgr sin theta.
अच्छा लिखा तो है minus mgr sin theta.
Okay, sir.
फिर ये माइनस माइनस प्लस हो गया. नहीं, ये तो माइनस के साथ है ना, ये
Yes,
ध्यान
sir.
दो ना.
Yes, sir.
ठीक है, ये
Yes,
हमेशा
sir.
कंफ्यूजन होता है. ठीक है, सो ऑलवेज टेक केयर ऑफ दिस थिंग. ठीक है, सो कैलकुलेशन खुद करना बहुत ही ज्यादा जरूरी है. Okay, so let's try to go for a next problem. Next we will just go for moving pendulum, and now let's try to analyze this thing little bit. So let's try to analyze this particular problem. This is also very interesting. What I have, the Lagrangian is L is equal to half m r dot square plus r square theta dot square minus half k r minus L naught whole square and plus mgr cos theta. यही है ना? Now you can put r is equal to L naught. If you will put r is equal to L naught, your spring pendulum is going to convert it into what? Your spring pendulum is going to convert into simple pendulum. है ना? So it is just going to convert into simple pendulum. Now you can check whether it is the Lagrangian of simple pendulum or not. So r dot is equal to what? 0. And that L can be written as half m L square and L naught square you can put. And this term will be 0 minus or minus plus mg L naught cos theta. Are you getting exactly same Lagrangian for simple pendulum? है ना? Now your length is L naught. There is not any problem. मिल रहा है ना? Just check it. So your simple pendulum is very basic system, and you have to always check your some complicated system by putting some constraint, and you can just get the final solution will be something like a simple pendulum solution. So this is a very nice trick that you can always check whether you are correct or false. आपने सही कैलकुलेशन किया है या फिर गलत कैलकुलेशन किया है. ठीक है. So let's go for a very nice problem that is basically known as what? A moving pendulum. So let's try to go for moving pendulum. यहां तक कुछ पूछना है आपको? Everyone is comfortable?
Yes, sir.
Okay, let's go for, this is one of my favorite problem. This is moving pendulum. Okay. Moving pendulum is very interesting. And this is my M1 mass. And there is a rod, and this is massless rod. And this mass is M2. And M1 is constrained, and this length is L. M1 is constrained to move in X direction. Okay. M1 is constrained to move in X direction. While M2 is constrained to move in XY plane. XY vertical plane. This is basically vertical plane. By the way, what is meaning of vertical plane and what is meaning of horizontal plane? Plane to plane ही है. Why I am always emphasizing vertical plane or horizontal plane? Just tell me.
So vertical plane parallel to the board and horizontal plane perpendicular to the board.
Very good, very good. But mathematically, what is difference? Very good answer. But mathematically, what is difference? What is difference between these two things? If someone will ask you, there is horizontal, the particle is moving in a horizontal plane and particle is moving in a vertical plane. Mathematically, what is difference?
In horizontal plane, y equals to 0.
Very good.
And vertical plane, z, sorry, s equals to 0.
Very good, very good. No, that is not the thing. Okay, plane is always plane. But when we are talking about vertical plane, that means we are talking about if there is effect of gravity. Are you getting my point? समझ रहे हो?
Yes,
Okay.
अगर पार्टिकल हॉरिजॉन्टल प्लेन में है so ग्रेविटी का रोल वहां नहीं रहेगा. Okay, and when particle is moving in a vertical plane, that means you have to take the role of gravity. Okay,
yes, sir.
good. So always you have to take care of this thing. Now, so this is in y direction. Again, I will go into g. So I have to take g in account, even if it is given or not given. Okay. Now, so first part. So what is equation of constraint here? How many equation of constraints? So, and where should be origin? Obviously, origin should be somewhere this point because M1 is itself moving. So where is origin? At this particular point, we have origin. So for first particle, if this particle will free, then this is x1, y1, z1. If this particle will free, this is x2, y2, z2. And what is going to happen? M1 is constrained to move along x-axis. That means what? Y1 is equal to 0 as well as z1 is equal to 0. ठीक है ना? Y1 is equal to 0 as well as Z1 is equal to 0. Now, for the second particle, it is moving in vertical XY plane. That means Z2 is equal to 0. And there is one more constraint, and that constraint is all about this distance is always fixed. So what is this distance? We can write x2 minus x1 whole square plus y2 minus 0 whole square is equal to sum L square. Are you getting my point? So
Yes,
there
sir.
are 4 constraints. So what is my DOF? DOF is nothing. 3 into 2, because 2 is the number of particle, minus 4, that is 2 DOF, 2 degree of freedom. So that means if we want to solve the Lagrangian, we always needed 2 generalized coordinate. Okay. Let's try to go for a first particle. What is kinetic energy of first particle? Half. If I will see this independently, the kinetic energy of first particle is half m1 x1 dot square. Yes, because it is just moving along line. Only this thing is there. Now the second particle is moving in a line or a plane. Second particle kahan move kar raha hai?
In a plane.
In a plane. And obviously the second particle will be m2 x2 dot square plus y2 dot square. Very good. Now, what will be potential energy for the first particle? बताइए, what is potential energy for the first particle?
0.
0. Very good. We can take it 0. What is potential energy for second particle? Minus m2 z y2. Sorry, this is also y2. है ना? Okay. Now, if I will write this thing as my Lagrangian, half m1 x1 dot square plus half m2 x2 dot square plus y2 dot square minus minus plus m2g y2. Is that this Lagrangian is correct? Is that this Lagrangian is correct?
Yes, sir, this is correct.
Is this correct? सोच करके बताओ.
Here is generalized coordinate is only 1. Generalized coordinates are not same as degree of freedom.
Very good. So what is generalized? How many generalized coordinate?
1.
There are 3 generalized coordinate. x1, x2, y2, isn't it? Why you are saying 1 generalized coordinate? जरा ये मुझे बताओ. क्यों कह रहे हो 1? क्या लॉजिक लगाकर कह रहे हो, जरा ये मुझे बताओ. I am very surprised if you are giving this answer. Just give me some. जरा बताओ क्यों कह रहे हो? What is logic? मैं भी तो समझूं कहाँ प्रॉब्लम हो रहा है. कैसे आपको लगा कि 1 है जनरलाइज कोऑर्डिनेट?
So it was wrong.
नहीं ठीक है, that is different issue. I am not talking about wrong and right. मैं ये जानना चाह रहा हूँ कि what is logic behind that? कि आपने क्या सोच करके दिया?
Sir, I was thinking that there is a x1 dot and x1. I was not observing this x2. I was
Okay.
thinking it is a x1
Okay, good,
dot
good.
and
Okay,
x1.
चलो, यानी कि देखने में दिक्कत हुई. Concept is okay. Good. Here we have 2 degree of freedom, but we are using the 3 generalized coordinates. So this Lagrangian is not correct. Okay, good. Now, just tell me, if I am talking about the second particle, what is the symmetry of second particle? ये किस चीज का इक्वेशन दे रहा है?
Equation of circle.
Equation of circle. Where is the center?
x1 0.
x1 and 0. What is the radius?
L.
L. So that means if I can change x2 and y2 in a equation of circle, isn't it? चेंज कर सकता हूं ना, क्योंकि x2 and y2 is moving on a locus of circle, but with respect to which point? with respect to this point. Yes, इस point के respect में ये circle के locus में जा रहे हैं. So, but I am seeing each and everything from this particular point. So first I will reach it there and then I will write the equation of circle. Are you people happy with this? सर्कल आपको कहां से दिखाई दे रहा है? यहां से दिखाई दे रहा है या यहां से दिखाई दे रहा है?
x1 0 से
x1 0 से दिखाई दे रहा है. तो मैं किसी तरह x1 0 पर पहुंच करके इसे सर्कल के में चेंज करूंगा ना. Mathematically, what I want to say, I can take this angle as theta. Why? Again, theta is with the vertical. Okay, because G is in the vertical direction. So I am just taking theta is in vertical direction. Now, this distance is what? X2. And this distance is what? X1. This distance is what? Y2. Now, can I write x2 is equal to x1 plus L sin theta? जरा बताओ सही लिखा हुआ नहीं? Just check it, just check it. This is your x2, this is your x1, and this distance is what? L sin theta. So this distance is equal to this distance plus this distance. Are you people happy? And what I can do, I can go for y2, that is what? L cos theta. Now you can see the motion of M2 is not independent to M1. The motion of M2 and M1 is actually dependent to each other. So what is going to happen? X2 dot is equal to x1 dot plus L cos theta, theta dot, and y2 dot is equal to minus L sin theta, theta dot. सही लिखा है ना? And now we can check. We have to write x2 square and y2 square. When we will go for x2 square and y2 square, each and everything can be written in term of x1 and theta. Yes? And then I just change my 3 generalized coordinate to 2 generalized coordinate. Let's try to go for this. So let's try to write the whole thing. है ना? सारे चीज को कैलकुलेट करने की कोशिश करते हैं. Okay. So I just want to remove all this thing. Chalo. So let's try to go for this. So my Lagrangian of a system is half m1 x1 dot square plus second is what? Half m2 x2 dot square plus y2 dot square. So we have to calculate this particular thing. So let us try to calculate it nicely. So I can put A, I can put B, I can put C. So A square will be always there. So we have x1 dot square. Now you can see B square plus C square. Which term is going to common? कौन सा term common आएगा B square plus C square के लिए?
L square.
Very good. L square theta dot square. Yes. And now you have cross term also. What is your cross term? 2AB, isn't it? So you have cross term and that value is 2x dot L theta dot. Let me remove all this thing. L theta dot, and you have basically cos theta is the part of this. So this is your kinetic energy. and your potential energy is minus minus plus, that is m2g, and what is your y2 is L cos theta. So now you can see this is x1 actually. Okay. Now how many generalized coordinate we have? How many generalized coordinate we have? 2. What is that? X1 as well as theta. And how many degree of freedom we have? We have actually 2 degree of freedom, and we have 2 generalized coordinate. Are you people happy?
Sir,
हाँ बताइए.
I think M2G L cos theta sir minus का
नहीं माइनस माइनस प्लस देखो.
प्लस तो
ठीक है.
हाँ सॉरी सर.
नहीं सॉरी की कोई बात नहीं. ठीक है. So now what is your cyclic coordinate here? ये पिछले बार गेट के एग्जाम में आया था. सेम प्रॉब्लम. What is your cyclic coordinate here?
Sir, x1.
X1 is your cyclic coordinate. Very good. So if x1 is your cyclic coordinate, then which quantity is conserved?
Px1.
Px1. What is Px1? So you can easily check del L upon del x1 is equal to 0. So x1 is nothing but what? Cyclic coordinate. X1 is cyclic coordinate. And then you can go for del L upon del x1 dot, which is nothing but px1, and this value is equal to, जरा कैलकुलेट करके बताओगे क्या होगा? Just take 30 seconds. बताओ क्या आएगा? I think you have calculated it. That is m1 x1 dot from here, m2 x2 dot from here, but don't forget this one. This 2 and 2 is cancel out. So you have m2 L theta dot cos theta. So this is your constant of motion. Yes, this is your constant of motion, and this is momentum of a system along x direction. So your momentum of a system is not only m1 x1 dot or m2 x2 dot, rather it will depends on theta also. And this is conserved. Why? Because there is not any force acting in x direction. So if there is not any force acting in x direction, so obviously momentum along x direction must conserve. Okay?
Sir, it will be m2 x1 dot.
Why
Or
m2 x1 dot? You have to, yes, m2 x2 dot.
x1 dot.
Sorry, x1 dot. Sorry.
Yes.
Thank you. M2 x1 dot. Thank you. M2 x1 dot. Yes. So this is a very nice system. And now you can again check whether it is correct or false. How you can check it? Can you make it simple pendulum? कैसे simple pendulum बनेगा ये? How you will make it simple pendulum? बताइए. If I will stop the motion of m1, then this will be just behave like a pendulum, isn't it? होगा ना? So just stop the motion of m1, then x1 dot is 0, this x1 dot is 0, this term is 0. What you will get? You will get, when I will put x1 dot is equal to 0, then what I will get? I will get half m2 L theta dot square plus m2 GL cos theta. This is nothing but what? Simple pendulum. Yes? So you can easily check any problem by if it is some family of simple pendulum. So there are n number of pendulum there. So now I am giving you one more problem, that is your homework. In the next class, I will do this problem as the next one. Okay. So just try to go for double pendulum. Okay. So this is fixed. This is M1. This is M2. This length is L1. This length is L2. So what is your double pendulum? Double pendulum is constrained to move in XY plane. Okay. So double pendulum, and obviously this angle is theta 1. I am just giving you parameter, and this angle is theta 2. So you have to write the Lagrangian as a function of theta 1 and theta 2. Okay. By the way, before going to this particular problem, can we find the degree of freedom of this problem? What is degree of freedom? So if first mass is free, then I can write x1, y1, z1. First, we will start from Cartesian coordinate. Then we will see what will happen to the transformation. If second mass is free, then you have x2, y2, z2. Now, this is moving in xy vertical plane. So I can write z1 is equal to 0 and z2 is equal to 0. So this is just a straightforward constraint. Now, second thing you can see, this length is fixed. ये length क्या है? Fixed है. So what is this equation? x1 minus 0 whole square plus y1 minus 0 whole square is equal to L1 square. Now, second is this length is fixed. Please, this length is not fixed. Are you getting my point? ये length fixed नहीं है. This length is fixed because you can just convert it into something like this. आप इसको देख सकते हो. Suppose this is my second length. It can go like this. So the origin from that, the position of M2 is not fixed. What is fixed? The distance between M1 and M2. So if distance between M1 and M2 is fixed, then you can go for x2 minus x1 whole square plus y2 minus y1 whole square is equal to L2 square. Now, how many degree of freedom is there?
So 2 degree of freedom.
2 degree of freedom. So you have to just go for 2 degree of freedom. Why? Because 3 into 2 minus 4 is equal to 2d of f. So 2 degree of freedom means you want to solve the problem with the help of 2 generalized coordinate. Now I can conclude that theta 1 and theta 2 is the 2 generalized coordinate. From where I will get this intuition? मुझे ये intuition कहाँ से मिला कि theta 1 और theta 2 दो generalized coordinate हो सकते हैं, and that can be measured from the vertical. From where I will get this intuition? बताइए.
Because theta 1 and theta 2 is changing.
Oh, from where I will get this intuition? Okay, you are 100% correct. Look at this equation very carefully. What is this equation? x1 minus 0 whole square plus y1 minus 0 whole square is equal to L1 square. What is this equation?
Circle.
Circle. What is the radius of circle? L1.
L1.
What is the center of circle?
0,
0, 0. This is your origin. So why I have taken theta 1, something like this. For the circular symmetry, we need r and theta. And here r is fixed. Look at r is fixed. What is going to change is this particular theta. Now go for the second one. Is that radius is fixed again?
Yes, yes.
This is equation
Yes,
of what?
sir.
Just look at the x2 and y2. This is equation of
Circle.
circle. Where is the center?
X1 comma Y.
X1 and y1. So I have taken this my angle. This is as my angle. Okay. This angle theta 2. Now this L2 is fixed. Now how you will introduce theta 1 and theta 2 in your calculation? That is the very interesting part. So just try to do it with yourself and try to post it. In the next class, I will start from this particular problem. And in the next class, we will try to finish this Lagrangian part. and then we will go for next level of analysis of Lagrangian, mainly for calculation of action, the understanding of equation of motion, and all this thing into after the one more class. Okay, so in next class we will again solve 2 and 3 more problem, and then we will go for a next level of Lagrangian formulation. Okay, so I think I must stop here. So if you have any doubt, you can just ask me.
Sir, all steps are clear. I have one confusion.
Yes, बोलिए.
I cannot think that how we can change number of generalized coordinate. How can we reduce generalized coordinate or increase generalized coordinate? As in
No, you need not to increase or decrease generalized coordinate. Listen, first write it straightforward into the Cartesian coordinate system. Okay?
Sir.
Okay. So first write it in a Cartesian coordinate system. And then just calculate the equation of, just calculate the degree of freedom.
Okay, sir.
Okay? And then in the process of calculating the degree of freedom, see the equation of constraint very carefully. You will have intuition that which coordinate system you have to transform it. Are you getting my point?
Okay, sir.
Okay. And after then, and once you will get in this coordinate system, I have to transform. But yes, you have to always keep in mind from which point the symmetry is visible. And after then, what you have to do, you have to always try to match number of degree of freedom is equal to number of generalized coordinate. Are you getting my point? So always try to fix this point. The final conclusion will be number of degree of freedom is equal to number of generalized coordinate. So why I have given you homework, just try to do this thing with yourself. And then in the next class, just we will discuss कि कहाँ पर क्या हो रहा है. So what's your name?
Anubha.
Anubha. So Anubha, just you can post your solution. आपका जो भी solution आता है, try to post me. Okay? And then I will deal कि आप कहाँ पर गलती कर रहे हो. ठीक है? Hope आप सही कर पाओगे, है ना? आप बताओ फर्स्ट स्टेप क्या है? What is your first step?
First step is to find the degree of freedom and the equation of constraint.
पहले इक्वेशन ऑफ कंस्ट्रेंट करोगे तभी डिग्री ऑफ फ्रीडम
Then degree
मिलेगा.
of freedom. Yes,
ठीक है.
sir.
इसके
After
बाद
that,
हाँ, इसके बाद आप क्या करोगे?
sir,
आप पूरी लैग्रेंजियन को कार्टेशियन कोऑर्डिनेट में लिख लो. ठीक है? और कार्टेशियन कोऑर्डिनेट में लिखने के बाद आप क्या करोगे? सुटेबल कोऑर्डिनेट सिस्टम में उसे ट्रांसफॉर्म कर सकते हो. अब सुटेबल कोऑर्डिनेट सिस्टम आपको कहां से पता चलेगा?
constraint equation or symmetry.
वेरी गुड. कंस्ट्रेंट इक्वेशन एंड सिमेट्री. तो उसको जब आप ट्रांसफॉर्म करोगे तो जो भी आपको बेसिक कैलकुलेशन करना होगा वहां पर आपको ध्यान देना है. ठीक है?
Yes, sir, I will try.
जस्ट आप ट्राई करो और फिर मुझे पोस्ट जरूर करो ताकि मैं ये देख सकूं कि आप कहां पर फंस रहे हो, है ना? देन आई विल डिस्कस इट इन अ वेरी ट्रांसपेरेंट वे. सो आई डेलिबरेटली आई हैव गिवन यू दिस पर्टिकुलर प्रॉब्लम. ठीक है? चलो, थैंक यू.
Thank you, sir.
Thank you, sir.